Thanks, everyone. Can everyone hear me okay? Because I can't tell if my voice is traveling. So also, yeah, cool. Everyone's thumbs up at the back. That's good. Okay. My motivation for bringing this talk to this conference was to try to get across the idea that if everybody can start building their APIs using a kind of a standard way, a standard format of using Hypermedia, we can make the web a lot more of a usable place for developers. This talk is very much geared towards the people in this room who are creating this stuff every day. If we can all decide and agree that using Hypermedia is a good idea, we will automatically be able to kind of use the web as a way of being able to scale our APIs to high volume of traffic, to be able to use the facilities that the web provides to cache everything, and just to be able to make things better. And that's what I hope that everyone can take away from this talk, that using Hypermedia correctly and appropriately will help achieve that goal. So first of all, who am I and why am I standing here talking to you about Hypermedia? I blog a little bit on my personal blog at nocarrier.co.uk. I talk at conferences. This is my second talk that I've done on the field of REST in general. I also talk about a micro framework called Silex. I've been involved with the community for the PHP community for probably about 5 years or so now, maybe longer. I lose track of time, but I'm a software engineer and manager, and I work for the Invika group. Hence my t-shirt. The Invika group consists of Invika itself, Session Digital, and Sensio Labs UK. We are hiring, so I'm sure everybody's pretty much aware of that by now, but we always are. I'm from Scotland, and I love putting this slide up because I can put a massive flag of Scotland up on a big screen so everyone can see. Okay, so let's get into a little bit about what I'm here to talk about. And oh, actually, before I do move on to that, that's just some of my contact details there. So the first thing I want to talk about a little bit is the architectural styles of creating APIs on the web. There are many. Some of them are more successful than others. And we're going to run through a couple of the kind of the ones that we shouldn't really be following, some of the styles that they can work for certain situations, and sometimes it's okay. But there are some issues with those ways of working. We have lots of APIs use the web simply to tunnel data through. They don't use the protocol, they just use it as a way of being able to get a message from one place to another place. And a lot of those APIs look a little bit like this. RPC style APIs, you issue a GET request, include all of the information in the URL, and have things that change state on the behavior from just following a link. There are some reasonably obvious pitfalls of doing things this way. If that, for example, was a link that a web spider could follow, every 12 hours or so, when Google comes along and indexes your site, it ends up creating a new user account. And that's because we're not using GET in the way that it was designed. GET is supposed to be a safe method. You're supposed to be able to issue a GET request against anything on the web, and it will return a resource. It doesn't change anything to do with that resource. Yes, it can do some other things. It can increment counters. It can, you can do tracking statistics. You can do some other bits and pieces off of the back of having a GET request, but it shouldn't change the state of a resource. I just kicked that light. This works against the web. You can't cache that resource. This isn't a read-only resource. This is modifying the behavior of a server. It's modifying state on the server side. These APIs sit on a scale. And I'm going to go through each of the levels. There's 3 levels in this scale. It's called the richness and maturity level. And they describe how advanced an API is in terms of getting to level 3, which is titled The Glory of REST. APIs at level 0 are said to be sitting down at the bottom in the swamp of POCs, which is a great term. POC standing for plain old XML. This is where APIs have no semantic meaning. They're just blobs of data. They could be in any format, and you can consume them. You have clients that are very hardwired to understand the exact specifics of your API. Nothing can be implied or derived from those APIs. They have no semantic meaning. Or JSON. And we'll talk a little bit more about JSON later on. Yeah, anyway, I'll leave that for later. Here's a quick example of just a plain old XML file. Everyone's probably familiar with with this sort of thing. It's just an XML blob. None of these things really mean anything. They are written in English, of course, but you can understand them. But for a computer or a client that's trying to understand this API, it has to know exactly what each of those little bits mean, and it's very specific to your implementation. It's very domain specific. We can't represent something else using a similar format. We have to design another one. Another architectural style which lives in this richness and maturity level 0 is the WS star standards, and these are this is SOAP. All requests over SOAP are done using POST, an HTTP POST request. They don't use anything else. They're just tunneling data using POST and then re-implementing a whole bunch of features like caching, like any kind of metadata. Everything else has to be implemented in SOAP. We can't leverage anything that's out there using SOAP because it just uses it as a tunnel. SOAP clients are built off of using these WSDL files. The clients are very, very intrinsically tied to how you do how you use that API. This is okay if you're using a language that supports this really well, like Java. You can point Java at a WSDL API, at a WSDL. It pulls it down, generates a client on your client side, and you can just start using it. It doesn't work quite so well if you're in another environment, like in PHP or using something else. It's very complex. The SOAP envelope, if you ever actually have had the misfortune of having to dive into what the SOAP envelope actually looks like and what things are, how things are represented, it's really difficult to read. This is very much a machine, something that's targeted for a machine. So how do we get up to richness and maturity level 1 from sitting at the levels of RPC, XML RPC, and SOAP, that kind of thing? We hit level 1 by identifying resources. This is the pretty URLs part that lots of people think of when you say, I have a REST API. They think immediately, they jump into saying, oh, like, so you have nice little URLs which address things. Yes, you do, because the reason why we have those is because you're identifying resources using a name, and that name is the URL. So this is quite often what people think of when you say that you've got a REST API. What you don't have in a RESTful API usually is verbs inside the URL. This is quite a bit of a clue about whether or not your service or that your thinking is heading in the right direction for creating something that will exist on the web in a kind of web-friendly way. You find the nouns or the domain that you're trying to represent. Once you've found the nouns, you can address them. So take this example here. It's a simple statement. Users can create messages that are visible to other users who follow them. We have two things that we can identify from that statement. There's two resources that are interacting here. We've got users and we've got messages. Once you've identified those things, you can craft the URLs for those resources. That's appearing quite small on the screen, but it's but the idea being that you have something for users and something for messages underneath it. Then you can start thinking of resources being subsets of other resources. Users obviously have messages that are associated with them, so we can think of these things in terms of subsets of data. So my user so user/b Longden/messages is a kind of a logical extension to retrieving those subsets of data from my user resource. And this is in preference to things like using the query string to filter the base resource. You wouldn't necessarily want to go http//my domain/messages filter by my username. This provides a much nicer and easier way of getting access into those bits of subsets. So we've talked about using HTTP as a tunnel, like the plain old XML, plain old JSON type APIs, but HTTP is a protocol. The clue is in the P of HTTP. HTTP can represent these three different things. It has methods, it can represent metadata, and it can represent a payload. The methods are the 9 methods that are come as part of HTTP 1.1 that declare what action you're doing against a resource or against a URL. So that's get, post, put, delete, and some other ones which are lesser well known. It has metadata in the form of headers, and it has a payload, which is your message body. And these are the 3 things that you can express. So, and if we use those 3 things in the right way, HTTP is actually very successful. It's been running the web for 25 years. It can scale up from very humble blog sites, which get 1 or 2 visitors a day, right up to things like Facebook, which get millions and millions and millions of users a day. And it does this by being able to wrap up features which can be then re-expressed in intermediaries, so things like using caches. You can leverage all of those bits in things like a varnish cache or any other kind of reverse proxy. If you obey the rules of HTTP, you just get all that stuff for free on your API. By identifying resources and using HTTP, we're starting to climb up the ladder, up the Richardson maturity model, up to level 1. From there, by using the verbs that HTTP provides, we can get up to level 2 of HTTP. And written at the bottom there in small writing are the options, trace, head, connect, and patch methods, which are the lesser well-known HTTP methods. Some of these actions are safe. Head and get, as I've discussed, talked about get earlier on as being a safe action. You should be allowed to use a get or a head method against any resource, and it doesn't change the state of that object. It has no side effects. If you remember the first example of an XML RPC call which had to create an account, sometimes you see URLs that have delete in there as well. Those are really dangerous ways of using get, and it goes against the spec. It goes against what HTTP says you should really do. There are lots of things out there that will leverage the fact that get is safe, like caches, like all things of that ilk. It also has defined idempotent actions. By idempotent actions, I mean that the result of making 1 or more requests is identical. So the first request will make a change. Every subsequent request after that point will have the same effect. So to take an example, let's say delete. The first request deletes the resource. The second request ensures that it will mean that it's still deleted. You can't delete something more than once, so the item still doesn't exist. Therefore, there's no change on the server side. Head, get, put, and delete have those effects. Put is in there because if you update something and submit an identical request, the state of that resource is going to be the same. So when you're building an API, you need to identify the states that it's in and how those states map to the HTTP requests. Now, in the users and messages example, we have a few states. We have list users, list a single user, list messages, list a single message. The usual CRUD type operations on a user, and you want to be able to maybe follow and unfollow users. So this is kind of think of a kind of microblogging service. We could put search in here as well, but for the purposes of this, we don't need to. And the way that those might map to the methods are like this. We can get a list of messages from me, from the people who I follow. We can post a new message to my timeline. We can put to a message to update it if we made a mistake. I wish Twitter did this. I do this all the time, make mistakes and can't correct them. Or we can use delete to remove one. So from there, we've hit level 2. We're using resources to get to level 1. We've identified our resources. To get to level 2, we've started using HTTP methods to represent how we interact with those resources. And to get to level 3, we need to use Hypermedia. So what is Hypermedia? Hypermedia is expressed by, on Wikipedia, actually, as this. A logical extension to the term hypertext in which graphics, audio, video, plain text, and hyperlinks intertwine to create a generally non-linear medium information. Essentially what it is being able to put links into your resource that a client can follow in order to be able to represent data and interactions between your resources. There are 5 different types of links which have been identified. And all hypermedia types will exhibit at least one of these hypermedia affordances. An affordance is a bit of behavior. So what a hypermedia affordance is will become clear just as I go through these. We have embedded links. In HTML, an embedded link is an image tag, is represented by an image tag. When your browser sees that image tag, it will use that link in the src attribute to render in place inside that document an image. It doesn't necessarily have to be an image. In HTML, the image tag obviously would mandate that it's an image, but it could render anything in place. It's part of the document. So it's an embedded link. You have outbound links. These are your A in HTML5, your anchors. When that link is there, it's telling the browser that you have to go somewhere else to find out some more information. You have templated queries. In HTML, we do this using the forms with the get method. You can basically, all a form is a way of being able to get the user to be able to construct a URL by passing in parameters. When you click the submit button, the browser just takes those parameters and converts them into a query string and sends it back to the server. So it's a templated query. It can do non-idempotent updates. So this is creating new bits of information. In HTML, you do this using form method equals post. That's creating, the idea with this is that it's creating new bits of data. And following that, you can do, another hypermedia affordance is idempotent updates. HTML in general has no support for being able to do this. It doesn't have this as a feature, which is why you can't do puts and deletes using HTML. Some hypermedia formats will have ways of being able to express that. We can also look at, there are many, many different registered media types. HTML is obviously one of them. That is a hypermedia format. You can express links of 4 out of the 5 different types of links that are able to be expressed. But there are others which are really, really useful for making an API, a web API. That's not to say that you can't use HTML to do an API, and in fact that's been done quite a lot. It does offer quite a lot of support for quite a lot of things, but not being able to do puts and deletes can be quite limiting sometimes. A way of being able to do this is using another hypermedia type called HAL, which stands for Hypertext Application Language. This is a very, very simple markup which can be used in both XML and JSON variants. It's great for APIs, it's very simple. And it allows you to represent your resources quite easily and has built-in hypermedia controls. Now, the JSON format of HAL looks like this. you can see it has two reserved keywords. It has _links and _embedded. The only Hypermedia affordance that Hal has is the ability to be able to do outbound links. And for APIs, that is usually all you need to be able to do, is to link to what the next thing is that you're able to do. If you can see the slides from the back, you'll be able to see that inside the links object, you've got next and self. So this is representing a collection of bits of data, which we've paginated, and we're telling the client that in order to get to the next page, you follow the next link. It also has a link back to itself. We also have embedded items. So inside this collection, we've actually embedded the items that are in it. And those are things inside embedded. And we're going to talk a little bit more about that in a minute. Here's exactly the same thing represented in XML. It's maybe a little bit more, a little smaller. That's normally just because of the way I format it. So the point of using Hal is to be able to send things out in both XML or JSON formats. You can quite easily support it. And a bit of a shameless plug is I've written an API that allows you to generate Hal format, the Hal format. It's in my GitHub repository, and it's all linked to from these slides, which I'll post after this talk. You can generate them in PHP. You can create this representation quite easily. You define one way of being able, you define one Hal resource, and then you can spit it out at the bottom. Unfortunately, it's just chopped off a little bit at the bottom, but it says as XML or as JSON, and you can format your API output in that same way. You can format your resources using those things. So the next thing we're going to talk about is some link relations. Now, link relations are what you name your links. In that example, we had two examples of outbound links. You have next and self. Link relations should have a short syntax if you're using one that's actually registered. You're probably already familiar with one of these things. Whenever you link a style sheet to HTML, you have a thing in your head, inside head. You have the link. You have the link tag, and you say rel equals style sheet, and then a link to the style sheet. That is a link relation. What you're saying is that in order to format this page correctly, follow the style sheet link relation, pull down that bit of CSS, and use it to render this content. There are loads of those things that are registered. Style sheet is one of them. There's another one called profile, which is a useful one of being able, a useful way of being able to say that this is what this resource is. This is what it represents. You can put stuff at the end of a profile link relation that says, if it's a JSON file, you could put some JSON schema over there to do some validation. There are ways of being able to name links so that clients can automatically follow them if they understand what they are. A browser understands style sheet very well. All browsers do, so it's a common way of being able to do it. And these things are registered in two different places. And I'm going to try and follow these links and see if this works. One of them is a site called Microformats. Let's just see if I can. There's something quite appealing about being able to do a hypermedia talk and formatting it up using HTML, which is a hypermedia format, so it's a bit meta. But just an example, this is the registry for microformats. This is where all of these things, or some of these things, can be registered. These link relation types, and you've got some quite interesting ones in there. So you can see there are a lot of them. Some of them are more useful than others. For example, there's one here. If you can't read that, which you probably can't, it says crush. And this is a way of being able to say the definition, this person considers the referenced person to be a crush, i.e. they have a crush on the referenced person. Friend, represents the current document, considers the person represented by the reference document to be a friend. Now these are quite obviously added by a social network. I'm not quite sure which one. You can register your own ones of these. Microformats is a really good one. In fact, actually, you can see style sheet is there. The style sheet a style sheet, just defined as a style sheet for the current document, uses the invisible link href element. There's lots of them. Sibling, spouse, oh, sweetheart. So those are the registered link relations. There are other places as well. You have a sort of more formal registry, Ayana. And they have their list of registered link relations as well. There are some of these that are slightly different. There's some are in microformats and in here. They're kind of, and the other way around. It's worth having a read through these when you're designing Hypermedia APIs to see if there is some of these things that are actually going to make sense. One that is quite useful is, there's one actually that is in there. It's called edit. When you represent something and call it edit, what you're saying is that the client can put and delete to that URL to edit the current resource. So that's a way of being able to say that you can represent links to say, I want to be able to edit this resource or delete it. This is the link you should use to be able to do that. You can edit or delete against that particular place. So those are quite useful. Those sites are quite useful. But of course, sometimes you want to be able to create your own custom link relations. And the way that you should do that is, a lot of the time you can just create a word that you might want to use. The problem is if you just create a word and don't register it, is that somebody else could use that same word in another public API. And you've got a clash. Your version of my relation will clash with somebody else's definition of my relation. So when you're creating custom link relations, you should namespace them by just using a URL. And this actually provides quite a useful feature. If you use a URL, you can actually make sure that that URL can be dereferenced. If you follow that link, you can stick some documentation at the end of it to say, this is what this relation means. So other people can start using that as well. And if it becomes, if lots of people use it and think that this is a really good idea to be able to have a standard way of representing this thing, so that my client, which understands these links, can be used against multiple different APIs, they're able to do that. And I'll show you why that's a cool idea in a minute with Hal. So things to consider when you're designing a hypermedia type. We'll run through a few of these things. Should I be representing it in XML or JSON or HTML or YAML or any of the other different markup languages that are out there? It's really tempting and really easy just to pick JSON these days. Everybody wants to use JSON because it's easy. It's everywhere. If you're using JavaScript, it obviously becomes very, very simple and easy to parse. But it actually forms quite a rigid structure to an API. You can't evolve it very easily. And I'll show you an example of exactly why that is in a minute. XML is also ubiquitous. You can parse it anywhere, but it's harder to parse. But XML is evolvable and quite easily evolvable. And what do I mean by that? Take this example in JSON. This is a really simple the JSON object. Has two parameters. It has name and phone. If I wanted to add in functionality to my API, say this is a representation of a user that's been sitting there for a number of months. People have started coding coding clients against this representation. But I want to add the functionality to be able to support more than one phone number. My JSON has to change to this. We've changed it from something that has a string in phone. We have to change it to something that has an array. And that's going to break the clients that are currently speaking to it. If we do the same thing in XML, it looks very similar. We just have name and phone. Because of the way XML works, and because it's a lot more evolvable as a markup, we can just simply add another phone, and the parsers that are out there will just handle this. You're not going to break your clients. A normal parser will just pick the first one, and they will continue to work as they were before. The clients that are built to use the new version of the API will be able to recognize the fact that there's more than one phone number now and take advantage of that. So JSON is a really tempting one to use because it's so easy and basically parsing XML is a massive pain. But actually, if you want to make your APIs a lot more evolvable and able to move forward into the future and accept changes that you're going to make to them, XML can actually be a really good choice. Consider your hypermedia factors. What sort of links are you trying to embed? Do you need to be able to have embedded links? Do you need to be able to make non-idempotent updates? Do you need to extend an existing format? Like I said, Hal only actually supports outbound links. You can extend that format, you can use the facilities that Hal already has, and you can add stuff to it to be able to support things like templated queries. That's okay, and people are doing that, and there are ways of being able to extend formats. There's a number of registered hypermedia formats, things like there's one called collection plus JSON. And if you look up collection JSON, there is an actual way of being able to extend it to be able to do lots and lots of other things, and then push those extensions back into it as a standard so that other people can follow those ways of doing things. But all this sounds really great, but why? Why would I want to use a registered type? Why can't I just stick together some XML or just stick together some JSON? If you haven't guessed already, the benefits of doing that is that there are existing tools that support this stuff. And this is another link here as well. This is not that important that you can actually read this. It's just that I wanted to show it because it's actually it gets across the message quite well. This is actually a Hal browser. It's obviously built on the web, but it's what it does is it allows you to issue requests off to a Hal API and be able to derive things from it because it understands the Hal format. And this is actually an API called FoxyCart, which is a Hypermedia API. It's a very good one. It's one of the better ones that I've seen out in the wild. And you can see that on the right-hand side, you can see the raw Hal information. It contains a whole bunch of links and lots of custom relations. So you can see these, if you can see the slides there under the /rels. But what it's doing is it's, on the left-hand side, it's parsing out those links and saying, well, actually, because I'm a Hal browser and I understand the Hal protocol, it's able to provide ways of being able to follow those links and say, right, well, if you want to issue a GET request against it, you can just click that green button. So I'm able to actually use this to browse an API. And because the custom link relations are using URLs, they've stuck some documentation at the end of them. So by using a Hal browser, I can then click on the documentation, and I get a little bit of, obviously, he's not quite finished the documentation, but the point is there that you can just follow those. You can follow those links, and you can pick out bits of information that are useful to the developer who is using the API. Because Hal can't provide a way of being able to specify whether or not something is a GET request or you should use something else against it, you also have a facility to be able to use the Hal browser to be able to just to issue a different type of a different method. Okay. So what we get by this is interoperability. If everybody starts using these defined and registered media formats, I can build a client like a browser, like that Hal browser, and point it at any Hal API, and I can just start using it by clicking around. I can just start using it, but I can build a generic client that can follow the links inside the document because the client can already understand what those things mean. And if I'm using registered link relations, I can even interact with some of your links quite easily. I can say, well, if I discover the registered edit relation, I can immediately provide a delete button that will work against your API without me ever having seen your API before. This stuff will already start to work. This becomes really cool when you start thinking about closed platforms, like developing client applications for an iPhone, for example, where you have a long lead time to being able to create a client, submit it to the App Store, wait 2 weeks for them to review it, and then that thing goes on, that thing becomes available to everybody. if I'm using a Hypermedia API, I can actually control what that client looks like by just providing links. So my delete button might only appear if there is an edit link there on the resource. So I can change how the client looks through being able to provide different types of links and associating the relations with them. When you start getting into some of the Hypermedia stuff, you end up with this Chatty API problem where you make a request to a server, you retrieve a resource, and you think, right, well, actually, I want to get messages, so I want to go off and find the messages straight away. So you immediately make a second request to the server to pull back the messages. So that's 2 HTTP requests that you didn't necessarily need to make, because I could have gone straight there. And there's a way of getting around this. This is called Zoom, the Zoom pattern, or the hypertext cache pattern. And it looks a bit like this. This is a HAL representation again. I've provided 2 links, again, one to the current document, and one to all the messages. This is going back to my example of the microblogging platform. I provided messages as a link, so if you want to get all the messages that are my messages, you follow that link there. However, what I've done inside the query string is I've specified what I want, what link relation I want to zoom in on, the bit that I'm interested in, the messages itself. So rather than making an initial request just to get the link and then following that link relation, what I've done here is specified, well, get me the resource, but go ahead and zoom in on the messages one so that I get all the data that I'm looking for immediately. And what happens is that this is the beneficial thing about being able to use a Hypermedia format that supports being able to embed other resources. The messages will appear in that one resource. So I can get everything I'm looking for from my API just by doing one HTTP request. And if you do this, you're hitting one of the many constraints and guides that were put together for RESTful web services. Using a common interface to be able to talk to any API that is created, using the registered link relations, will enable the web to hopefully become more usable, hopefully lend it to becoming better for developers to be able to use, less painful every time you want to implement an API. You'll be able to talk to multiple different services using the same format, so there's not thousands of different ways of doing it anymore. And if you can do that, then everything will just be better. And that's it. Thank you very much.
Now, do we have any questions? We've got a question over here.
Hello. How do you handle version updates? So if you have a new version of the API, what would you do?
That's a question that gets asked quite a lot, actually. If I was being if I was being really sort of purist about it, I would say don't version. The reason I say that is because if you can use something that will allow your API to evolve, you shouldn't need to break backwards compatibility to a point where clients don't understand the new version. They shouldn't break. If you do need to do that, one of the best ways currently of doing it, and this stuff moves on all the time and changes as people are working on these things and this stuff all the time, so the recommendations change. But the current best way and agreed best way of versioning is actually use different link relations. So you say, well, this link relation is version 1 of this resource, and then you can provide another link, a different link relation to specify the version 2 of that different resource, and you do that just using just using those versions. One thing to avoid is using the URL. Try not to put version numbers inside the URL because it is the same resource. It's just the representation that's changed. Okay.
Yeah.
Just a short question. How do you handle authentication, in this model?
Yeah.
Like, for instance, if we have a system that needs to recognize certain user, and this whole kind of this whole thing about sessions that we are used so much in the web.
Yeah. HTTP comes with the kind of basic and digest authentication, which can be used for kind of simple auth. You can identify users and just include the authentication header with every single request. If you need to go a little bit deeper than that, you've got things like standards like OAuth, which people use quite a lot in order to get a token, and you just identify with every request, and just carry on and just do it like that. Yeah. There's one down here at the front.
Hi there, it's just a bit of a follow-up on the authentication question.
Yep.
Obviously, REST services are quite cache-friendly,
yes.
but often resources can change the links they have depending on how you're authenticated.
Yep.
So how do you get around that problem with the cache?
When you get into using using caches, you can vary on various different headers. So as long as you've got the caching stuff set up correctly, you can vary on different characteristics of a request. So you can say I want to not cache this if one of these particular headers is different. A lot of the time when you get into things that are authenticated requests, you can only cache the ones that are kind of just a single user cache. You don't necessarily want to be able to share that information. You can start to get into things like using proxies, like edge-side includes, and using Varnish to pull common bits of data and pull those things together, and that works quite well. But yeah, you do have a problem when your service is purely authenticated only. You don't want to cache things because the representations are different for every single user. But yeah, there's a few different ways of doing that. But the vary header alongside your representations allows you to differ caches based on the contents of that. Yeah.
Hi. Is it possible to use things like WebSockets or HTTP streaming in Hypermedia API?
Yeah, you can. Well, one of the things that you can do with Hypermedia, one of the REST constraints is being able to, one of the constraints is to actually push code down to a client. It allows you to do that. So things like using JavaScript, you can push JavaScript down the wire to a client and get it to initiate a WebSockets connection. That's usually just something that happens on the web and is very much an HTML5 feature. I guess it's possible to use REST over WebSockets, but I don't think that's ever happened. WebSockets is more of a protocol rather than a style. So, any more? Okay, I think we're done. Thank you very much.